By the end of the lesson, I will be able to simplify exponents using the product rule and use exponents to solve expressions that require order of operations. So here is an example of 8 squared. 8 is the base, and the base number seen in the list of numbers. So it's the number that we see listed. So if we had 8 times 8, that would be the base number in the list. And the exponent is 2, and that's how many of the base there are. You need to take note of this. So they are not the same. Notice that we have negative 2 to the 4th power, and we also have negative 2 to the 4th power. So no parentheses actually means negative 1 times 2 to the 4th power, and parentheses means 1 times negative 2 to the 4th power. So notice that the negative goes with the 1 when there are no parentheses, and the negative goes with the 2 when there are parentheses. So written out, we have negative 1 times 2 times 2 times 2 times 2. There are 4 2's, which indicated by this 4 right here. And then we have 1 times negative 2 times negative 2 times negative 2 times negative 2. There are 4 negative 2's. If I have negative 1 times 2, that's negative 2 times 2 is negative 4 times 2, negative 8 times 2, which is negative 16. If I have 1 times negative 2, that's negative 2, times negative 2, that's positive 4, times negative 2, that's negative 8, times negative 2, that gives me 16. So notice what the parentheses do. The one on the left with negative 2 to the 4th without parentheses is actually a negative 16. It's a negative answer. On the right-hand side, when there are parentheses, our answer is positive because a negative times a negative is a positive, and a negative times a negative is a positive. We're going to write using exponents. So we're going to rewrite in exponential form. So my base number is the number that I see listed. So the number that I see is listed, which is 20. And then you have to ask yourself, how many 20s are there? And there are 1, 2, 3, 4, 5, 6. So 6 is my exponent. So 20 to the 6th power. Looking at number 2, there are 2's in my base. How many of them are there? 1, 2, 3, 4, 5, 6, 7, and 8. So we're going to have 2 to the 8th power. Looking at number 3, our base is going to be 14. And how many 14's are there? 1, 2, 3, 4, 5. So 14 to the 5th power. Number 4, 7 is the base. It's the number that we see listed. How many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7 to the 9th power. So rewrite in exponential form. I don't have to solve anything. I don't have to find a really big number. I just need to write it in exponential form. So rewrite the following as a single exponent using the product rule. This right here is very important to you, the product rule. It means that when multiplying the same bases, you can just add the exponents together, right? So when we're multiplying, so when I have, in this first example over here, we have 9 to the 6th power times 9 to the 2nd. So 9 is going to be my base, and what I'm doing is adding the exponents, so 6 plus 1. So I'm going to have 9 to the 7th power. That's only when I'm multiplying. Right? Only when I'm multiplying I can add the exponents. So I have negative z. Make sure that you have your parentheses around your negative z. I have negative 5 plus negative 11 in my exponents. So negative 5 plus negative 11. So I'm going to have negative z raised to the negative 16th power because negative and a negative are going to join forces. The next one, I have negative 7 as my base. My exponents, I have 4 plus 6. Do you notice how I'm showing my work? I'm adding the exponents. I'm making sure that they're up. So 4 plus 6 is in red. You need to make sure you show that as your work. So I have negative 7, and then I have 10 as my answer. So rewriting the following as a single exponent using product rule, Negative 7 to the 10th power means the same thing as negative 7 to the 4th power times negative 7 to the 6th power. So I have 3 S's. I'm going to do the same thing. Because I'm multiplying, they're all squished together. I have negative 4 plus negative 5 plus negative 6. So I'm going to have S raised to the negative 15th power. 1/3, don't let the fraction scare you. 1/3 is just 1/3 written in my answer. I have 5 plus 2. So my answer is going to be 1/3 raised to the 7th power. Same thing with the negative 1D. It might look scary, but really I'm just going to write negative 1D in my parentheses. And I'm going to have 11 plus 13. And I'm going to have negative 1D raised to the 24th power. All right, last time we wrote it in exponential form. So this right here, the 10 to the 3rd power, is exponential form. Because there's an exponent. And now it's wanting us to write it in standard form. And standard form just means a number without an exponent. So we're going to have to evaluate 10 to the 3rd. We're going to go the other way. So we're going to have 10, and we're going to write 10 3 times. So 10 times 10 times 10, right? 10 is my base, so it's the number that I'm going to see in my list, and 3 tells me how many times I'm going to write it. Then I'm going to probably want to use my calculator for some of these, and I'm going to do 10 times 10, which is 100, and then I'm going to multiply it by 10 again, and I get 1,000. So 14 to the 2nd power. So I have 14 as my base, and I'm going to write it 2 times because I have an exponent that says 2. I'm going to multiply 14 by 14. So 14 times 14 equals 196. Notice that I'm writing out 14 squared. This is how you show your work. If you do not show this part of it, then you're not showing your work. Make sure you show your work. So I have 4, and I'm going to write it 5 times. So my base is 4, and my exponent is 5. So 4 times 4 is 16, times 4 is 64, times 4 is 256, times another 4 is 1,024. Last one, 5 3 times. 5 times 5 times 5. 5 times 5 is 25, times 5 is 125.